let's explore this a bit more using another example. Let's take this case where, to keep it simple, let's call this case 3, and two spheres of equal mass, both have mass m, and both are traveling with the same velocity u towards each other, right? So this is like if you have seen a Newton's cradle, then you would have seen some spheres hanging by a thread, and if this is one and I lift the other one and leave it, drop it, it will move towards this. And then what happens is, if this is A and this is B, the next instant A becomes stationary here and B starts moving in this direction with the same velocity. Right? So typically what happens is they exchange velocities. A comes to B was at 0, A becomes 0. A was moving with some velocity, now B will move with the same velocity. That is what would happen here also. Two objects of same mass moving towards each other and colliding with the same velocity or even different velocities, they will just exchange velocities. So the velocities will be exchanged. So let's calculate momentum and energy in this case. What will be the initial momentum of the system? Again, the system means both these masses, no other external impulse of force. The initial momentum is mu of this plus mu of the second sphere, right? But u, if we take this as positive direction, then this u is negative, so this will be a minus u. So mu, the second one becomes minus mu, so the initial momentum is 0. What happens to the final momentum? Final momentum is again, they start moving in the other direction. So let's say this, after collision, the first ball moves this way and the second one moves the other way. So it will be minus mu plus mu, which is again 0. So if you see, the momentum before collision and after collision is the same. What happens to the kinetic energy? Kinetic energy is nothing but half mv square, we know that. So after collision, the kinetic energy will be, before collision, the kinetic energy, which is called initial, let's call this final. The initial kinetic energy will be half m u square plus half m u square. The sign of velocity doesn't matter because we are squaring it, and energy is a scalar quantity, so it doesn't matter really. So half mu square plus mu square is mu square. What is the final kinetic energy? Again, the velocities are exchanged and the same, so it is half, and direction doesn't matter in velocity, plus or minus, because we are squaring it, plus half mu square, which is mu square. So the kinetic energy initial is equal to kinetic energy final. So this is a case of perfectly elastic collision. This is elastic. Now let's look at inelastic collision, or rather perfectly inelastic collision, where two balls which are made of glue stick to each other, the same, let's consider the same m and m, moving towards each other with the same velocity u, just to demonstrate the concept. And after collision, what happens? This is before, and after, what happens? They stick to each other, m and m, and then the velocity becomes 0. They stop, they stick and stop, so 0. So now let's calculate the same momentum and energy in this case. Let's see what happens. This is inelastic, right? This is inelastic. The initial momentum, the final momentum, kinetic energy initial and kinetic energy final. So the initial momentum, as we can see here, is mu. If this right, this is positive, then minus mu for the other one. This is 0. So after collision, again they come to rest, so it is totally 0. So the initial momentum and final momentum are um, matching and equal to each other. Momentum is conserved. In elastic collision also momentum is conserved. Momentum is conserved here. And let's look at the kinetic energy. The initial kinetic energy is again half mu square plus half mu square, which is mu square. Half plus half is 1, so mu square is the initial kinetic energy. What happens to the final kinetic energy? Half mu square will be, the velocity is 0, so 0 plus 0 is 0. So the kinetic energy is not conserved in the case of inelastic collisions. Kinetic energy not conserved. Why is that? I mean, since they stick to each other, there will be a permanent dent, or this will get deformed here, and all the energy is spent in all those. There will be some more friction, or so on and so forth. Let's not get into those details, but the kinetic energy is not conserved in the case of inelastic collisions. Whereas for elastic collisions, momentum is conserved. So momentum is always conserved. Kinetic energy depends on the coefficient of restitution, or rather whether it's inelastic or elastic collisions. Thank you.